Okay, here we're going to be looking at saturated and unsaturated fats. As we see from the initial picture here, saturated fat is a very linear organization, and unsaturated fats here have the presence of a double bond, creating this little bit more of a jagged appearance here. So we're going to look at this more on a little bit of a molecular scale, but this gives you that quick comparison of a saturated versus an unsaturated fat that contains at least one double bond. So fatty acids can be saturated or unsaturated. Those are two main classifications. For saturated fats, which are mostly animal fats, there's single bonds between all carbon atoms. So if you want a way to remember saturated fats, think of it saturated with hydrogens because there's all single bonds here. So there's the maximum amount of hydrogens located on this molecule. Unsaturated fats are typically oils, mostly plant fats. And they contain one or more double bond between carbon atoms. We see this line here indicating a double bond. This double bond, as compared to our saturated fats, will mean there'll be less total hydrogens here compared to saturated. So unsaturated fats have less total hydrogens and they have this double bond. This double bond causes a fixed point, and this can cause a change in the overall shape of our fatty acid. And I think this picture kind of shows a nice representation of that. Again, saturated fats, you see saturated with hydrogens because it's all single bonds. However, unsaturated fats only need one double bond. And that double bond can be in the cis orientation, where we see both hydrogens are located on the same side, and we have a trans orientation where they're located on opposite sides here. So that double bond fixes those two carbons when they're bonded together, and as a result we can have a cis form where they're both on the same side, or we can have a trans form where we have one that is below the other one there. So keep in mind, saturated is all going to look the same. Unsaturated only needs one double bond, and that could be in a cis or trans form. Those saturated fats are typically solidified when they're cooled. They can raise our cholesterol. They're very stable. Our unsaturated fats are considered to be more of our good fats. They don't raise your cholesterol. They're a little unstable, and they do not solidify when cooled. This is why these typically are oils and considered good fats. The saturated ones are kind of the butters and things we may like, the ice creams, the cakes. Those are saturated with hydrogens, and these are typically have negative effects in the body where we're raising our cholesterol. That saturated and that unsaturated, again, here's how our chains look. Highlighted the unsaturated double bond here in the cis form, but this gives you an idea from that first image of how our saturated fats look like a very nice tight line, and unsaturated fats have at least one double bond. In this case there's two. This has a little bit more of a notched appearance located here. Comparing our fat composition, so oils, as I said, have less of those saturated fats and a greater portion of those monounsaturated, which would be one double bond, or polyunsaturated, which would be multiple double bonds formed there. Dairy products, you can see a much higher portion of saturated fats and little to almost none of polyunsaturated fats. And here's some other meat products here just to give you that kind of general comparison. Looking at some other classifications here, we have our nuts, sweet and baked goods, and you can see just on a quick comparison the change in the amount of polyunsaturated fats. And same here, butter, very high percentage of saturated fats. So again, just a good comparison and a good resource to look at and compare. As I said, those cis and those trans forms, cis being on the same side with that double bond, trans being on opposite sides here. We get to see how different those molecules look. Now, important to remember these because trans fats do not occur in nature. So fats that look like this, where hydrogens are on opposite sides, believe it or not, do not occur in nature. We see an evidence here of that trans fat. So what they do exist, but they don't occur in nature. Well, they occur typically when we process foods. So the cis structure in your body is able to process and maintain its cell structure. You can read here. Trans are not helpful for the body and linked to cancer and heart disease. So it's very important of the structure of these molecules and how it impacts our body. Artificial trans fats are created in an industrial process that adds hydrogen to liquid vegetable oils, making them more solid. So there's a advantage here in the processing industry, which is why some of these have been created. The primary dietary source for trans fats is processed foods and is partially hydrogenated oils. As a result, and now we're seeing the negative and linking these negative effects to these trans fats, we're now seeing them required to be on nutrition fact labels. So foods are required to state trans fat on the label. So take a look and know what you're eating. As a result of this, companies are now going about different ways to achieve the same end result without creating trans fats because of their negative impacts on the body. However, now, with the label laws having companies required to state this, you can easily check to see if there's any trans fats in the food you are consuming.